And then you have, in these squiggly lines, observed temperature. So what we see is that the models and the temperature record agree really, really well. Like the model can take the inputs and actually simulate very closely what the observational record is showing us, which is, an increase in temperature. If we take the human component out of that model, the model cannot replicate the warming, right? So you've basically taken the CO2 forcing out, which is the human component, and you said, okay, pretend humans aren't on the planet and CO2 is averaging 300 ppm. The model says there should be no warming. So that decoupling between the observational record and the climate models tell us, again, what we already know is that human activity has a warming impact on the planet. But predicting where that warming will go, the magnitude and the impending feedbacks from the warming is a lot harder. So climate scientists will use different CO2 scenarios in the models to try to predict what are we doing as humans. Are we actually going to, are we going to just keep burning fossil fuels and keep emitting CO2 at the current rates? Are we going to be able to kind of reduce it long term? Are we able to kind of reduce it after a little bit? Can we turn it around right now? The reason that's important is because depending on the scenario, the magnitude of overall temperature change globally is different, right? Which makes sense. If we emit more CO2, there's going to be a stronger warming effect than if we emit less CO2. Any questions? Following me? Making sense?
Actually, I have a question. So CO2 obviously comes out not just from fossil fuels. There are a lot of other sources that CO2 comes out of, right? So when they in calculating that, do they calculate just specific fossil fuels? Or is it like all the other, like burning half of California, right, wood, like you get all of that too. So how is that CO2 calculated into their equation?
I think when you look at the amount of CO2 released from you're burning half of California, right? Like a forest fire, like a big forest fire, feels like you're putting a ton of CO2 in. The atmosphere relative, though, to what global CO2 emissions are from airplanes, cars, etc., negligible.
So it's still mostly just that.
Yeah. So this is just the human component. This would not include a natural prediction, because it's hard to, how do you predict nature, right? Too, so you don't know what's going to happen. Again, inherent challenge to the climate prediction piece is all those uncertainties, not just with humans, but with nature itself and the associated feedback. So, great question. So, a lot of uncertainty with where climate's going, and I think, the way I try to think about the climate emergency is with respect to tipping points, right? So you hear a lot about 1.5 degrees C and the Paris Accord, right? The whole world's got to try to limit global warming to 1.5 degrees C. It's with respect to tipping points, right? You can kind of push, you can kind of perturb Earth's climate, and eventually, it'll come back. But at what point do you push the climate past a tipping point to where now it's in a different state, right? So climate's hanging out here in regime A, and we're kind of slowly pushing that ball up to the tipping point. And at what point does that tipping point come down and fall into somewhere like a fundamentally new climate system, right, that we've never seen before, and how fast does that happen? And so I think when you look at some of the climate modelers that say, okay, let me take the different warming scenarios and try to understand how those warming scenarios will impact climate and the environment. 1.5 degrees Celsius of overall warming is where the climate models tell you, okay, you're going to have a big problem with sea level rise because you're going to start to melt a whole lot of Greenland and some of Antarctica. You're going to have fundamental changes in weather patterns, right? And some places are going to get drier and some places are going to get warmer. So that 1.5 degree line of demarcation is the theoretical tipping point to where if you can keep warming under 1.5, you can reduce the short-term impacts of abrupt climate change. If you go past that, now you're really playing with fire. And so when you look at kind of our progress, right, in the targets, so 1.5 degrees was the Paris target. Right now, it's predicted that the current pledges and targets get us to like an average of like 2.6 degrees. You know, if you're really optimistic, 2.1. The current kind of policies get us to 3, so really like, you know, there's a pretty big gap between like all the pledges and commitment that has been made to the climate conversation and what we actually have to do, right? There is still a massive gap between 1.5 and 2.1 or 2.5, depending on how you're looking at it, right? And so this, I think, this gap is what makes some people very nervous, right? And it makes that oh man, we got to get off of fossil fuels tomorrow, and we're all headed for extinction as a society because we're going to miss this 1.5. And I think this is where the narrative gets lost and people get emotional, because ultimately we know in this room that like getting off fossil fuels is not a possibility, right? So climate, you know, I think the climate alarmists probably leverage this public fear to believe that we're in this irreversible hurdle of Earth's climate. Sorry, I lost my water. Shoot. And I think they have, you know, so, and this is where like the conversation comes in about, okay, we've got to go to wind and solar and other types of energies as soon as possible. Perfect, thank you. So here are some talking points that when you're having a conversation, maybe you go back to the office today and, you know, tell your coworkers you saw a mediocre talk on taking back the narrative, right? And you're trying to talk about, hey, you know, we can accept climate's real, but here are some talking points maybe that, you know, when you're talking to people about energy, you're talking to people about the environment and what should we do as a country and really globally, hopefully you can use these. So point 1, electrification does not mean decarbonization, right? So back in January, President Biden, during the State of the Union address, talked, I think it was the first time he openly admitted, hey, look, we're gonna need fossil fuels for at least 10 more years. And people were kind of like, you know, haha, 10 more years, we're gonna need it for a lot longer. So the Energy Information Institute, this graphic got circulated on LinkedIn a whole bunch after that, because when we look at global energy, you know, consumption by source worldwide, the EIA, the U.S. Energy Information Administration, tells us, yeah, okay, we're going to see a really big increase in renewables. That's true. Well, natural gas is still going up. Coal's kind of flat. Petroleum is going up. So when we look at kind of where our energy comes from in 2050, yeah, renewables are going to play a much more prominent role in where we get our electricity from, but man, coal and natural gas and petroleum products are going nowhere, right? And that's, I think, the global view on energy, right? Is that like, you know, the U.S. is only 10% roughly of global CO2 emissions. So even if the U.S. went net zero, there's still 3 billion people in the world that don't have access to this type of energy, that countries like China, right? How I forget the exact stat, but like how many coal plants a year is China bringing on right now? Like, does anybody know the answer to that?
I think we have 7.
7 a year?
No, 7 this year.
7 coal plants this year alone in China, right? Mm-hmm. You know, and they're probably trying to increase that.
Yeah, we're building up. I don't think it was that many last year. I think we have more this year.
Yeah.
Just because of shortage of energy.
I read an article the other day that talked about, you know, the world, at least the modernized world, has shunned Russian oil and gas. Well, guess what? The Chinese and the Indians are taking so much Russian oil and gas. Russian oil and gas production is actually increasing because they're selling so much to China and India in other countries. Short anecdote, and this is what hit home to me. Last year I was coming back from Dubai, and it was an overnight flight, and it's like 2:30 in the morning, so you leave Dubai, you go up the Persian Gulf, and an hour into that flight, we're coming up to the southern Iraq, and I'm looking out the window at like 2:30 going like, man, why is the sun coming up at 2:30 in the morning? It's like you start to get that orange, glow on the horizon. And then, a few minutes later into the flight, and I look at the map, and it dawned on me, that's not the sun coming up. That's all the flaring going on in the South Iraqi oil field. I mean, flares probably the size of this building. I mean, it's just crazy from 40,000 feet, the scope and the extent and the size of the flaring. And it's like, the average citizen in the United States that doesn't think about stuff like this can't appreciate truly what this industry is already doing, right? US emissions per capita are decreasing, which is a good thing. But in the global scheme of energy and climate and CO2, it's a small piece, right, of what actually needs to be done. And this graph kind of hits home for me that, electrification doesn't necessarily mean decarbonization. But let's think about a scenario where, I don't know, maybe it is possible, right? And we want to try to go to all renewables here in the US as quick as possible. So the IEA, which is the International Energy Agency, I believe, put a great study out like a year or two ago that looked at the supply chain for renewables, and it's kind of crazy. So essential to clean energies, solar, but wind, right, EVs, they need batteries, they need magnets, right? And these require a ton of materials, precious metals, rare earths, nickel, lithium, cobalt, copper. When you look at oil and gas and you look at fossil fuels, so this graph is showing you the market share of the top 3 producers of each of these commodities. So the top 3 producers of oil and gas, US, Saudi Arabia, and Russia, make up about 40% of market share globally. And the US has a very prominent role in that. We control our own destiny when we think about our energy security. If we have to start depending on other countries to source the materials for the supply chain, it's kind of scary. Look at cobalt. The Congo, so the top 3 countries that produce cobalt make up almost 80% of the market share for cobalt today. And the Congo is about 70% of that alone. China has a huge control on rare earths and graphite. South Africa, platinum. Australia and Chile, lithium. So you don't see the U.S. a whole lot, on these mineral supplies. It's kind of scary, right? Because we don't control our own destiny anymore. And to get those minerals from those countries, it's, look, open pit mining is not exactly the most environmentally friendly practice in the world, right? And a lot of mining in those countries that you just saw happens in regions where there is growing climate risk, right? And so this graph that the IEA put out shows just how vulnerable some of these metal supplies are to water stress. It takes a lot of water to produce copper and lithium. Over half of copper and lithium is sourced from areas that are at extremely high risk of water stress, which is, kind of concerning, right? When you think about, in a changing climate where the wet get wetter, the dry get drier, that's a big risk. Even ones like zinc and nickel, I think that's those are uncomfortably high percentages. Bonnie?
On your last slide, I had recently learned that in the Inflation Reduction Act that there's language around limiting how long we can import certain rare earth minerals within like 2 or 3 years, and then it's going to subside. And so there's a projections that solar is going to take off and there's going to be a lull because we're going to have to build mines. I don't know if you have heard
I'll
that
get to the
story.
building mines, yeah. Well, and another funny thing, right? So, like, again, you know, if we're going to be if we're going to be trying to go to solar renewable, right? Because fundamentally, what you're doing with these technologies, you're going from like you use fuel to make electricity, right? Coal, natural gas, it's a fuel. You put it in a power plant, it makes electricity. Now you're asking to go to a material-based electricity system where you need all these raw materials to manufacture the technology to make the electricity. And there was a chunk of land in Nevada that was being prospected by a mining company for lithium or I don't know the mineral. So the Biden administration goes, oh, it's a national monument now. Off limits. Can't mine it anymore. So, you know, that's the policy of this is a whole nother conversation, right? Around like what our politicians are legislating and regulating versus like what we have to do to make this a reality. It's so decoupled. And anyway, but I'll get to the mining thing in a second. Okay, so electrifying everything doesn't mean we're going to decarbonize. It's not a promise. Mining is not exactly the most environmentally friendly, nor, you know, it's susceptible to climate risk. Anybody seen the book Cobalt Red recently? So the social cost of mining is probably even worse than the environmental cost. So Siddharth Kara is not just some like arm-waving, tin hat wearing conspiracy theorist against renewables. He is a Harvard professor who studies modern day slavery. And I would encourage you, I'm not gonna play the video, but if you don't wanna read the book, he has a 2-hour podcast with Joe Rogan where he talks about his experiences in the Congo. But in a nutshell, in the Congo has 70% of the world's cobalt supply to date. Mostly Chinese-owned companies that are layers and layers and layers and layers away from the boardrooms of Tesla, Vestas, etc., employ modern-day slavery, kids 6, 7, 8 years old with picks filling bags with rock and walking them out of a pit. It's horrifying. And he is a Harvard professor. He made 4 or 5 trips over there. He wrote this book. It's shocking how little coverage it has received. I'm about halfway through it on Audible. It's probably the number one. I've never been more moved by a book than this book. And look, we're all guilty of it. Smartphones, like our smartphones have cobalt. Cobalt is used to optimize battery charge. So we're all kind of guilty of it, and there's really no way you can't get this Congo source cobalt out of the supply chain. So the social cost is pretty ugly for mining some of these materials. But let's say we can figure out how to, we can clean it up. So we can find ways to more sustainably harvest these minerals, and we can do it and be better on the social aspect of it. We have this problem that China dominates the supply of these minerals to market. So think back to the first graph I showed, right? All of these nickel, copper, lithium, cobalt, rare earths are sourced in countries, not in the US, different countries across the world. Most of that material gets shipped to China. And then China then does a lot of the processing and manufacturing of that. So look at the rare earths. 80% of rare earth processing occurs in China. Now they own the market of that. Look at cobalt. Cobalt, 75% of the world's cobalt supply comes from the Congo. China processes almost all of it, right? Here in the United States, there are some locations in California that mine lithium, and then they put the ore and they send it to China because they can't get the environmental permits to process those metals in the US, so they have to ship it to China. China processes it, and they make the batteries, and they make the batteries, they make the magnets, and all of that. So it's a supply chain for clean energy tech that we don't control. So let's say the US has this epiphany and we start permitting mines and we start permitting the processing, we start allowing companies to process metals here in the US. Oh, I'm a slide ahead, sorry. So not only does China kind of dominate the supply chain for these materials, demand is going nowhere, right? And so in the IEA report, there's two different scenarios. So the STEPS scenario is kind of like okay, this is the present day, everyone's made these pledges. The SDS scenario is like a net zero by 2050 type scenario. So in a net zero by 2050 scenario, this is total demand, which is kind of harder to understand in terms of kilotons, but look at just overall demand growth. Lithium is this kind of like darker blue. In a by 2040 in a net zero by 2050 scenario, you're going to have to increase your lithium 43 times present day production. In a kind of conservative approach, you still need to have about a 12 or a 13 times increase in lithium. Let's see, nickel, you need just more than 40 times current production to satisfy net zero by 2050 goals. So you need a ton of these metals to scale these technologies. So let's say the US wakes up and they're like, oh, okay, we got to do something about this. Let's start mining in the US. It takes 15 to 20 years from discovery to first production to get a new mine off the ground. So if you did something today, it would be 2038 before you started producing. So this is, again, straight from the IEA study. Some places like in Australia, they have a 4-year lead on lithium, which is pretty good. But like nickel can be up to 20 years. Copper, 16 years. So it takes a long time from the time you study or you find a reserve. You got to do all the environmental due diligence, all the feasibility studies, all the hoops. Then you got to plan the construction, and you got to actually build it. It takes a long time to get these mines off the ground. And so, to me, when you kind of look at, we were talking about regulatory headwinds, right? What we have to do in this country and globally relative to what's feasible today, there's a massive disconnect. And so what you're going to see happening, and I need to pick a LinkedIn fight with someone later, not in this room, but, someone was arguing last night, that prices for lithium are going to start to go down. And I wonder how that happens, because what's going to happen ultimately is that, we're teetering right now here in like 2023 on kind of break-even points for most of these minerals, right? So the dark blue is operating mining for copper, lithium, and cobalt. And then the light blue is kind of current mining capacity under construction. And then the red and yellow lines are basically demand curves. So again, the steps, the yellow line is kind of a conservative present day pledge scenario. The red is the ambitious net zero by 2050 scenario. And you see that either way, you start to have supply gaps between these materials and the mining capacity that's currently present. And so I think this is going to be a massive, when we think about how do you scale and how do we get Earth off, how do we get the planet off fossil fuels, and hey, we got to do everything we can to go to these clean, renewable energies. I don't disagree. But when you look at the supply chain logistics of doing it, it's very sombering. And there's a lot of hurdles. And you go, okay, well, maybe the natural gas route isn't that bad of a route right now, especially globally, right? In places like China where, I was talking to someone from Goldman Sachs, they were investors. Europe cares a lot about the carbon footprint of LNG. Asian countries don't, right? And so, but here in the US, we have the ability to supply a relatively clean load of LNG to those countries. And so you start going, man, like, you look at this and it's like, oh, it's like, I'm not against it, but it's just, man, like, President Biden said 2 weeks ago, he wants, with those new emission standards, that like 60% of cars have to be EV by 2032. Like how? Like, I don't know. I just don't feasibly see the supply chain allowing such rapid expansion of these technologies as being requested. Even if they did, here's the other issue, the grid, right? Like the grid doesn't get a whole lot of coverage these days, but I mean, Alice Jackson is the chief planning officer at Xcel. If you don't know her, she's phenomenal. And she was telling me 22% of our energy needs come from the electrical grid today. So 22% of the electricity that you consume in your day-to-day life today comes from the electrical grid. In 2050, 76% of your energy comes from the grid. So in an electrified world, we are far more reliant on the electrical grid than we are today. We have 240,000 miles of transmission line in the United States. We currently build at an average of 1,700 miles a year. So if we maintain that rate, trying to overhaul the grid, it's going to take 84 years to expand the energy grid 60%, 140 years to double it. I think 240 to triple, that's a typo. But that's kind of, again, logistically, you look at it and go, oh, it's going to require copper, right? Copper is going to be constrained by the supply and demand market. So just, again, this is just another point where I just think about, when you're having conversations with folks, it's like, man, I'm not trying to deny clean energies at all. I love clean energies, but yikes, like I just don't see the path right now for us to go net zero anytime soon. So I'll leave it there. Hopefully we have time for questions, about 15 minutes. Look, the takeaways from this talk, climate's changing. Let's all agree on climate change and global warming, that burning CO2 has an impact on the planet. Let's stop having those debates right now. And let's think about, having conversations with, we all support these energies, but how can we scale them better? How can we diversify the U.S.? How can we mine more? How can we do it cleanly? How can we do it more humanely? Regulatory is going to have to play a big role in it. We're going to have to think about the grid. And whether people like it or not, our industry is going to be around for decades to come, because it's going to take oil and gas ultimately to facilitate the transition. And with that, hopefully I'll have some questions for me. Question?
I had a question just about the records that we've kept, because obviously what we can record and monitor today with our sophisticated equipment 200 years ago, 100 years ago, 50 years ago didn't exist. So how can we project back when we have this incredible way of monitoring? And I know you said you can find stuff from the ocean, but I mean, like, I don't know. That just seems mind-boggling.
Yeah. So there's two parts there. First, I share your thoughts with modern day weather records. So, Denver is a great example. The weather station for Denver was first at Confluence Park in the 1870s. And then it moved to Stapleton Airport, and then it moved to Denver International. We all know that in the summertime, like Denver International and downtown Denver are two different microclimates. And I've done a little bit of like research into it, right? Because it was last year they were talking about, there's just been, in the last 20 years, Denver's seen an increase of X days of 100. Well, yeah, but they also still keep the weather records at the old Stapleton Airport. And 25% of the 100-degree days in Denver, the increase in 100-degree days is explained just from the location, right? And so like I've had that same question for like the climate people, is like, how do you, like, it doesn't explain all of the increase, right? There's still like a warming signal in there, but like the magnitude isn't as big as you want to say it is, because that weather station in Denver's moved 3 times, and Confluence Park and DIA are totally different, not to mention like what was like some guy in 1870 reading a mercury thermometer versus like the very precise instrumentation we have to measure temperature today, like I have troubles with those types of statistics, because it's like, well, yeah, I'm not saying there's not a